See Lindelof videos. Evaluate the definite integral. And what I want to talk about here is definite integrals of trigonometric functions. And I want to use the fundamental theorem of calculus, FTC. And the fundamental theorem of calculus, just to give you the definition, says that if you want to evaluate the definite integral of f of x dx between the values of a and b, it is simply to find that parent function and to evaluate that from a to b. So the way that most people see it most simply is this, that the definite integral a to b of f of x dx is equal to parent f of b minus parent f of a. So this is what we're chasing right here. So we're trying to get to this. So all I'm going to do is start by doing some simple integration. I am going to keep in mind that I have these upper and lower bounds that I have to deal with. But I'm going to integrate this, and if I integrate 2, it goes to 2x, right? How do I know that? Because the first derivative of 2x is 2. So that's get there, right? And the integration formula for cosine x is sine x. So this plus sine is this one plus sine x. And I'm just writing that because this is not always true. It's in some other ones there's a negative, but in this case it's not. It's just sine x. And now I'm going to tell my AP reader that I intend to evaluate that from here to here. All right? So this is just good notation for your AP reader, so he or she can give you all of your points. And then I want my AP reader to know that now I am going to evaluate f of pi minus f of 0. And remember, it's parent f. It's this. This is the parent function. Okay? Here, I just want to be a little bit careful here. So I'm just going to draw an arrow to show you what I'm doing. I'm saying I have 2, it's 2x, but x here is pi, right? Plus sine of pi. Well, sine of pi, I'm just looking at the unit circle here. Pi is right here, and the sine value is 0. So sine of pi is 0. So I have 2 pi plus 0. You don't have to show all this. I'm just showing you where I got it. This negative sign right here is this one right here. In this case, it's not going to be very important for you to know that, but I just want you to keep that in mind, that formulaically that this negative sign exists. Now I'm going to interpret this, and I'm going to say, okay, and now I'm going to take my f of 0. So I have 2 times 0. It says plus, so plus sine. In this case, it's sine of 0. So this thing doesn't make much difference. Sine of 0, I have to think about this because not everything of 0 is 0, but sine of 0, here's 0 right here, and the height value here is 0. So sine of 0 is 0. So we have 2 pi plus 0 is 2 pi minus 2 times 0 is 0 plus 0, right, is just equal to 2 pi. I want to say to you again, as always, please be careful when you do definite integration. It does not always give you the exact area. It's not always area. Sometimes it is, sometimes it isn't. But you can't assume it. You've got to take a close look at that function. So, having said all of that, the fundamental theorem of calculus, indefinite integration of a trigonometric function, this is how you do it. Thanks for watching. If you have any questions or comments, please let me know. And if you haven't already subscribed,